Dear friends, in today's lecture, we are going to understand the basics of tensor, how we will create tensors, and how we will do data manipulation tasks using TensorFlow. So, in this lecture, we will deep dive into the concept of tensors, like building blocks of TensorFlow and their implementation, their manipulation. This includes tensor creation, operations, reshaping, and broadcasting. And by the end of this session, you will have a strong understanding of how tensor works and how to effectively manipulate them for machine learning and deep learning tasks. So let's have a recap of our previous session. So a tensor is a generalization of vectors and matrix to potentially higher dimension. It is essentially a multi-dimensional array. And what is tensor rank? Tensor rank refers to the number of dimension or axes of the tensors. And what is shape? Then shape refers to size of tensor in each dimension. Okay, we have also given some example about all of these things. So let's start with the hands-on creating the tensors. So we will learn how to create tensor using different TensorFlow method and explore their rank and shapes. So I have already written code for you so that it does not take too much time while writing the code. So right now I have connected with Google Colab environment, but here I have connected with CPU environment only. Here I'm going to change the runtime to the GPU. So in Google Colab, you can see that T4 GPU, TPU as well, Tensor Processing Unit. Okay. And I have already told you that TensorFlow and PyTorch are already compatible with GPU. And TensorFlow and PyTorch are a framework in which we are using to create our model, to train our model, because it is highly compatible with the GPU. So here in hands-on, we are going to create the tensors. So first of all, you have to import your library. So here we have import one library only, that is TensorFlow. So I am importing import TensorFlow as TF. Now creating a scalar, like how we will create a scalar. Scalar is a variable and TF dot constant, and we have provided parameter 5. So TF dot constant is used to create the tensor. Dot constant is used to create the tensor. So let's run the program and let's see what is the output of this program. I have run this program and you have seen that we have got a scalar. Now the second hands-on is how to create a vector. So here we have provided like some entity here 1.0, 2.0 and 3.0. And in vector, I have provided multiple element here. And using this line of code, I am going to create the vector. So you can see that our vector is now created 1.2.3 and its shape is 3 and its data type is float. And here you will see in scalar, when we have created a scalar, then there is shape is nothing, shape is blank. And while creating the vector, you can see shape is 3 because here are 3 elements. Okay. Now we will create the matrix. Matrix is 2 dimension. So now by writing this program, we will create the matrix. Creating a matrix equal to TF dot constant. You know, TF dot constant is used to create the tensor. Okay, and here we have passed the a value like 1 2 3 4 5 6, and by writing the print command we will see how our matrix is going to be created. So you can see my matrix is created. And what is the shape of my matrix? What is the shape of my matrix means how many rows and how many column in my matrix. So you can see that in my matrix, one row is with the element 1 2, the second one is 3 4, and the third one is 5 6. So my matrix have 3 rows and 2 column. One column is 135, second column is 246. So my matrix shape is 3 by 2 and its data type is integer. So I hope you have got now that how to create the scalar, how to create the vector tensor, how to create the matrix tensor. Okay, now we will create the 3D tensor. We will create the 3D tensor. Okay, so I'm going to run this program and you will see how we will create the 3D tensor by using same line of code. Yeah, only we have to increase some dimensions and we have to create the tensor. Okay, so our 3D tensor is tf dot tensor 1 2 3 4 5 6 7 8, and its shape is 2 2 2 2 2 2 means x y z. Okay, it has all the 3 dimension, that's why it is 3 dimension. Okay, now check the rank or dimension and shape. We will check the rank, dimension and shape of this tensor. Okay, So let's see what is the output. Rank of 3D tensor is equal to 3, shape is blank, and its data type is integer 32. Okay. So this is all about how we will create the tensor in TensorFlow. Okay, we have seen how we have created the scalar tensor, how we have created the vector tensor, and how we have created the matrix tensor, and how we have created the 3D matrix. Okay, so if the some important point related to our hands-on is scalar has no dimension, means scalar has rank 0, and vector has one dimension, means vector has rank 1. Matrix has two dimension, means matrix rank is 2. Now tensor can have any number of dimension, and TensorFlow can handle them efficiently. Okay. Now let's proceed our the next hands-on code, and our next hands-on code is tensor operation, arithmetic and more. Okay, we will see how we will perform some operations like addition, multiplication, and other operations. Our objective is to perform operation on tensor, including addition, multiplication, element-wise operation, and matrix multiplication. Okay, so a TensorFlow support a variety of operations such as element-wise operation, means addition and subtraction, matrix multiplication, broadcasting for operation and tensor of different shape. Okay, so first of all, we have to create two tensor. So here I am going to create two tensor, tensor A and tensor B, using the code like tf.constant and 1, 2, 3, 4, and the second tensor is tensor B, and it's 5, 6, and 7, 8. Okay, so let's run this program and let's see what is the output. Okay, so my program has been successfully run here because I did not write print command here, so my program did not printed anything here. Okay, and my tensor is now created by because my program has run successfully. Okay, now we will do element wise addition. Okay, so let's see what is the result of this program. So our element wise addition program is result add is a variable, and we have write the code tf dot add and tensor A and tensor B. We have to add two tensor A and tensor B. That's why we have write the program here tf dot add. What you have to do in TensorFlow, you have to do addition of the two tensor. Okay, which tensor? Tensor A and tensor B. After that we will print the result. Okay, now let's run the program and see what is the output. Okay, now see, you have seen that what is the output. Tf dot tensor 6, 8, 10, 12. It's a element wise addition. Now I will show you how the element wise addition has been happened. You can see that here is our first matrix like 1, 2, 3, 4. Okay, we will get a 2 by 2 matrix, and our matrix element will be 1, 2 in single row and 3, 4 in other row. Okay, so it's a 2 by 2 matrix. Okay, and our second matrix is 5, 6, 7, 8. So it is also a 2 by 2 matrix. Okay, so in first row of first matrix it's 1, 2, and first row of second matrix is 5, 6. Then we will add element wise in each element of both row of the matrix. Okay, so I will add 1 to 5, 2 to 6. So it will happen 6, 8. Then after that I will add 3 plus 7 and 4 plus 8. So it will happen 10 and 12. Okay, so after doing the element wise addition I will get 6, 8, 10, 12. You can see here that we have got 6, 8, and 10, 12. And our shape of matrix is 2 cross 2, 2 row and 2 column, and data type is integer 32. Now the second operation is element wise multiplication. We will do element wise multiplication by writing this piece of code like result of multiplication. It is a variable, and we have assigned tf dot multiply. Okay, tensorflow dot multiply. What you have to multiply? Tensor A and tensor B, and we have now printed the result, and result is this 5, 12, 21, 32. So it is element wise multiplication. So it is element wise multiplication. Element wise addition has been done. Now we will do the matrix multiplication, and it is not element wise multiplication. We will have to apply some algebra concept into it, and we will get the some other result that is different from element wise matrix multiplication. Okay, but here shape and data type will be same. The shape of the matrix will be same. So now in this hands on we have defined two tensor. We have done element wise addition, we have done element wise multiplication, and we have done matrix multiplication as well. Okay, so element wise operation happen by matching element from corresponding position, And matrix multiplication is not a element wise and follow the matrix multiplication rule. Some algebra concept we have to apply into that. And TensorFlow automatically optimize operation for performance, especially on GPU. Okay, TensorFlow automatically optimize operations for performance, especially on GPU. So now our next hands-on is broadcasting in TensorFlow. So we should know what is broadcasting. After that only we will go to the hands-on. So our objective is understanding broadcasting. So how TensorFlow allow operation on tensor of different shape by stretching one of them. So stretching the shape of tensor is known as broadcasting. Broadcasting allow operations between tensor of different shapes. Broadcasting allow operation between tensors of different shapes. As long as certain conditions are, TensorFlow will automatically stretch the smaller tensor to match the shape of larger tensor. So which tensor will be stretched? The tensor which have less dimension that will stretch to the larger dimension tensor. So as an example, a 2 cross 2 matrix can be added to a 1D vector by broadcasting the vector across the rows of matrix. Here our 2 by 2 matrix means our matrix has 2 rows and 2 columns, and we have to add a vector into our tensor. We have to add a into our matrix that is one dimension. So what we will do, we will stretch one direction matrix into two dimension matrix, that is known as broadcasting. So here is the hands on for this. Broadcasting a 1D vector to match a 2D matrix. Now our matrix is given as tf dot constant 1 2 and 3 4. This is our 2 by 2 matrix, and our vector is given as tf dot constant 1 2. It has only one dimension. Now we have to apply broadcasting into that. Okay, we have to do addition of both of element. One is matrix and other one is vector. Vector have low dimension and matrix have higher dimension. Okay, so we have to stretch the dimension of we have to stretch the dimension of vector to match the dimension of matrix. After that we will do addition. So result of broadcast is equal to tf dot add matrix and vector. After that we will take the print and see the result. Okay, so by writing this program, we can do addition of matrix and vector by using the broadcast concept. Okay, so here our matrix and tensor both has been added. Our matrix and tensor both has been added. Okay, so what has been done here? Our matrix element are 1 2 3 4, and our vector element is 1 2. So 1 2 is added into first row element wise addition of the first row of our matrix. Okay, so 1 plus 1 2 and 2 plus 2 4. So our new matrix is 2 4 3 4, and its shape is 2 by 2, means 2 row and 2 column. So by using broadcasting concept we can do operations on different dimension entity like matrix and vectors. Okay, so now in this hands on we will see broadcasting across higher dimension. Broadcasting across higher dimension. So we have a 3D tensor and we have a vector. So by using the broadcasting concept, we can also apply this concept and can do addition of these two matrix and vectors. Okay, so here is the result of this. Okay, now the next hands-on is reshaping and slicing of the tensor. But before that, we have to discuss about some key learning point. So TensorFlow automatically broadcast tensor of smaller dimension to larger dimension when necessary. Okay, so it's a inbuilt property of TensorFlow. TensorFlow automatically broadcast tensors of smaller dimension to larger dimension when necessary. And broadcasting simplify code by eliminating the need to manually expand a tensor. Okay. Now the next hands-on is reshaping and slicing of the tensor. Reshaping and slicing of the tensor. Okay. So our objective is manipulate tensor shapes and learn how to extract specific data from tensor using slicing. So reshaping allow you to change the dimension of a tensor while maintaining the number of element. So this is the crux of reshaping. What we have to do? We have to change the dimension of tensor while maintaining the number of element as it is. We don't need to change the number of element, only we have to change the shape of the tensor. Okay. Slicing allow you to extract part of a tensor for a specific operation. Okay. So we will do this hands-on in our next exercise. Till then, keep exploring and keep learning machine learning and deep learning.